In the reaction, HCl3 negative plus HPO4 2 goes to H2CO3 plus PO4 3 negative. The conjugate acid base pairs are, first you identify your bases. They're usually the hydrogen acceptors. For these equation, it's these two. So then you have HCl3 and you just add a hydrogen, and then for that one your conjugate acid is right there, and then you have which goes to, and those are your conjugate acid base pairs. What is the H concentration in an aqueous solution in which OH is equal to 1.2 times 10 to the negative fifth? For this problem, since it just wants the concentration, you use your formula for pH. Which is HOH. So you have OH, so you just plug it in. And then you divide by 1.2 times 10 to the negative fifth on each side, and your answer comes out to 8.33 times 10 to the negative 10. Calculate the hydroxide ion concentration in a solution with pH equals 6.389. So then you have your pH equation, which is the following. Since they already gave you pH, you go ahead and plug in 6.39 plus POH is equal to 14. So you know that POH is equal to 7.611. And from there you do 10 to the negative 7.611 and you get a concentration of 2.4 times 10 to the negative 8. What is the pH of 15 ml of 0.0045 molar of HNO3? For this one, you're just going to do the negative log with a 0.0045, and it's going to give you a pH of 2.35. Because of the equation, pH is equal to negative log of H. What is the pH of a 675 milliliter aqueous solution containing 0.036 moles of NaOH? So first you have to get your molarity. So you do 0.036 moles divided by 0.675 liters, which gives you 0.0533. And then you use your pH equation. And this is going to give you the OH, which is 1.27, and then you subtract it from 14 to get your pH, and this equals to a pH of 12.73. What is the pH of a 2.5 times 10 to the negative 2 molar acetic acid solution they give you a Ka of 1.8 times 10 to the 5th. So this is your equation, and you know that you have 2.5 times 10 to the negative 2 and 0. And then you do your ice. So you know what this is going to be. And then you plug it into the formula. And since this x is so small, you can go ahead and disregard it. When you solve for x, you get x is equal to 0.00671. And you can go ahead and plug it into the pH formula. And you get a pH of 3.17. What is the conjugate acid of HS? So you know that HS is a base and it's going to accept a hydrogen. So you just add a hydrogen to it, and that's your answer. We're trying to figure out the rate of formation. So we use the rate formula for this equation. So we have rate is equal to negative delta CO2 over 6 delta T is equal to negative delta H2O over 6 delta T is equal to positive delta C6H12O6 over delta T is equal to delta O2 over 6 delta T. So they're telling you that the rate of formation of O2 is 0.002. You can go ahead and separate your 1/6 and put 0.002 because they're already giving you the rate of formation of O2. So when you solve for that, you get 0.003. Calculate the VP when 198 grams of sugar is dissolved in 435 milligrams of water at 35 degrees Celsius. So the first step that you have to do is get your 435 milliliters of water, and you divide that by your molar weight, which is 24.15, and you do the same thing for sugar. And you get 1.10. After this, you're going to plug it into your formula, which is that's going to give you 0.956, and they're already giving you this value right here, so then you just multiply 42.18 times 0.956, which is going to give you 40.34, and that's your answer. Calculate the K equivalent at equilibrium, and they're giving you the concentrations for NO2, which is 1.125, and then 2O2 is 0.053. So your formula for K equivalent is products over reactants, which is right here, and since they're already giving you the concentrations, you just go ahead and plug it in. So then your answer is going to be 0.295. Identify the conjugate base of the HClO3 in the reaction. So you know that acids, this is your acid, and your bases are the acceptors. So then you can do is disassociate this. So you know you're gonna have your H plus the ClO3 minus, and this will be your conjugate base, which is A. Calculate the pH of a solution containing 0.20 grams of NaOH and 2,000 milliliters of a solution. So first you have to get your molality, which is just the 0.2 over 2 liters, which is equal to 0.1. And from there you can go ahead and use your pH equation. And you get that the P, in this case you will be getting POH because it's NaOH. And it's gonna give you 1. So then now you subtract 14 minus 1, which will give you your pH. So your pH is equal to 13. The pH of tomato juice is about 4.5. Calculate the concentration of hydrogen ions in the juice. To calculate the concentration, you just do 10 to the negative pH, and since they're already giving you a pH of 4.5, you just do 10 to the negative 4.5 is going to give you a concentration of 3.2 times 10 to the negative 5. Which of these acids is stronger, H2SO4 or HSO4 minus? So right here you know that this will disassociate into this because this associates like this. So then you know that HSO4 negative is a conjugate base, therefore the stronger acid will be H2SO4. In comparing 3 solutions with pHs of 2, 4.8, and 5.2, which is most acidic? So you identify where each one is at. You know that your pH goes from 1 to 14, and the higher it goes, the more basic, and the lower it goes, is more acidic. So then you have 2 about right here, 4.8 about here, and 5.2 about right here. So the closest to 1 will be the most acidic, which is going to be your 2. Identify the conjugate base of HSO4 minus in the reaction. So what you can do is you can do your own reaction for HSO4 negative and disassociate it. So then your answer would be, for the conjugate base, would be this one. Calculate the pH of a 1.6 KOH solution. So for this one, since it's KOH, you're going to be calculating first the POH, which is the same the negative as the pH equation, which is a negative log of the OH. So then this is the negative log of 1.6, which gives you negative 0.204. And then from here, to get your pH, you subtract it from 14, but since it's negative, you will be adding it. So your pH is 14.21. Identify the conjugate base of CH3COOH in the reaction. So right here, you can, instead of looking for it here, you can just, so you won't get confused, you can disassociate CH3COOH, and then you would get your H ion plus the CH3COO negative. So your conjugate base is this one. Write the Lewis structure for ammonia. So you know that ammonia is NH3. So then you're gonna have N, your 3 H's, and in order to fulfill and you're going to need 2 lone pairs, and that's the Lewis structure. The Lewis dot symbol for S-2 ion is. So first you want to check how many valence electron sulfate has. So you go to your periodic table and you find that it has 6. And right here it's telling you that they're adding an extra 2. So it equals to 8. So when you draw it, you know that you're going to have the usual 6 plus these 2. You can go ahead and put a -2 just to indicate that you added 2.